Hello, my name is Raquel Bunke, and I am a student at the University of North Georgia. I've been working with my mentor, Dr. Guavabarra, on our research, developing and implementing machine learning models to analyze EEG data using MNE libraries. EEG, or electroencephalography, is a method used to record electrical brain signals. These brain signals are generated through brain activity, such as thinking. In our research, we focused on EEG data resulting from imagined speech. Imagined speech is when a person thinks of a word or a syllable but doesn't say it out loud. Being able to classify EEG signals with machine learning could help people who are unable to or have problems with verbal communication, such as people who have ALS. The data set we used in our research includes 21 subjects, listening to, imagining, and speaking 16 different English phonemes. The location of the channels follows the International 1020 system, as seen in Figure 2. The highlighted locations indicate the channels that are included in our data. Our EEG data is presented in CSV format with time as the index and the epoch, channels, and phone labels as the columns. EEG data is usually displayed as a time versus voltage graph, which is seen in Figure 4. This shows the EEG data for two channels, AF3 and F3. One of the ways we used MNE libraries is to visualize our EEG data. Figure 5 shows a visualization of all the channels color-coded by channel location. In order to prepare our data for processing, we had to split it into training and testing sets. We used 80% of the data for training and 20% for testing. Our data included 10 trials for each of the 16 phones, so we used 8 of the trials for training and the remaining 2 trials for testing. We did this for each phone and for each subject. Data was further split into data and event files. The data files consist of EEG data for each channel and the corresponding time index. Event files consist of what phone is being imagined and at what corresponding time. We will be using convolutional neural networks and support vector machines to classify our data. Since our research is still ongoing, we have only been able to use the convolutional neural network. Our preliminary result achieved about a 50% accuracy. Our convolutional neural network trained for 3 epochs using the Atom Optimizer. In the future, we will use MNE for pre-processing as well. MNE includes independent component analysis. We could compare results achieved with the raw data versus the pre-processed data. In the future, we may also attempt to classify words as opposed to just phonemes. This would be very beneficial to our overall goal of helping people communicate. Thank you for listening, and I hope you enjoyed the presentation.